Hello to all my final year BSc students. Since because of lockdown throughout the state, we are taking virtual classes. So here the remaining portion about the partial differential equations which I have to cover. I have prepared the notes and the same thing is explained to you through this video. So we shall discuss about the general method of solving partial differential equations of non-linear type with two independent variables. So this method of solving this type of equations is called Charpit's method. Charpit's method is a general method for finding complete integral or the complete solution of non-linear partial differential equation. So the general equation, that is general partial differential equation, here will be of the form f of x, y, z, p, q equal to 0. Here z is a function of two independent variables x and y. What are the two working methods for this type? Step 1 is write the given equation in the form f of x, y, z, pq is equal to 0. Find the partial derivatives of f with respect to x, y, z, p and q. That is, partial derivative of f with respect to x denoted by dou f by dou x, and here you denote it by fx. Similarly, dou f by dou y equal to fy. Dou f by dou z equal to fz. Dou f by dou p is equal to fp. Dou f by dou q is equal to fq. So what is the step 2? After finding all the partial derivatives, you form the Charpit's subsidiary equation. This is a Charpit's subsidiary equation. So in this equation, you have to substitute all the values. So you have to remember this formula. So dx by minus fp is equal to dy by minus fq, dz by minus pfp minus qfq is equal to dp by fx plus pfz is equal to dq by fy plus qfz. So this is the formula, Charpit's equation. Now this Charpit's equation again written clearly over here. So here after substitution you have to take the appropriate two proportionals and solve for p and q. So once you find out the values of p and q, the step 3 is you know the total differential equation for z given by dz is equal to p dx plus q dy. Substitute the value of p and q in this total differential equation. So by integrating this total differential equation, you get the complete solution or the complete integral in terms of z. So this is the method of solving the Charpit's equation. So we shall take one problem. Solve by Charpit's method. First problem, z equal to pq. So write it in the standard form, that is f of x, y, z, p, q is equal to 0 form. So if you write it in that form, it is z equal to minus pq equal to 0. So now partial derivatives with respect to x, y, z, p and q you find out. So there is no x term in this equation, so fx will be 0. No y term, therefore fy is 0. So derivative with respect to z partially, fz is equal to 1 and fp is equal to minus q, you can observe, and fq is equal to minus p. So substitute these values in the Charpit's equation. So please write Charpit's equation in every problem so that you get used to it. So dx by minus fp is minus q So minus minus becomes plus q. So is equal to dy by minus plus p is equal to dz by plus pq plus pq. Substitution. P minus p into fp. Fp is minus q. Therefore minus p into minus q is plus q. Pq plus pq. So which becomes 2pq. So dz by 2pq is equal to dp by p is equal to dq by q. Now in this you consider the equation that is proportionals dp by p and dq by q. These are the only terms. You have to take the appropriate term to solve for p and q. So integrate this with integration. You have to integrate integral of dp by p is equal to integral of dq by q. On integration you get log p is equal to log q plus c, log c, constant of integration. So again removing log we get p equal to qc. Now you have here p is equal to qc. You have this value is substitute in the given equation. What is the given equation? Z equal to pq. Substitute for p. So z equal to c q square it becomes. So what is q now? Q is equal to square root of z by c. Because q square is equal to z by c. Therefore q is equal to square root of z by c. You got the value of p and value of now you got the value of q. Substitute this q value in p is equal to qc. So you get p is equal to c into square root of z by c is equal to solving. So here you have root c. C by root c is root c. Therefore this becomes square root of cz. So you got p and q values. Substitute this p and q values in the total derivative equation, that is dz equal to p dx plus q dy. So dz is equal to square root of cz dx plus square root of z by c dy. Dz is equal to, take that root z which is common in both the terms outside. Root z of root c dx plus 1 by root c dy. Now transfer this root z to the left hand side. So it becomes dz by root z is equal to root c dx plus 1 over root c dy. Integrating we get 1 over integral of dz by root z is 2 root z is equal to root cx plus 1 over root c y plus constant of integration b. So this is the required solution. So you can solve the first, you have solved the one problem. We shall take next problem.